plate.
I'm going to demonstrate the results of this
Except
amazing
for,
experiment.
you know,
with a bunch of
the
baseballs,
baseballs
and a barrier that we've
are
set up, which has two holes
almost
in it.
on the same scale
Now, normally
of
in the
mass
everyday
and
world,
size
if I throw
as the
baseballs
wall.
through one hole or the other,
you know,
they'll
there's
form
no
a predictable
gravitational
pattern
effects
on a
really
screen
between
that
the
we've set
wall
up behind
and this
home plate.
guy's
They'll be in
baseball,
one place
whereas
or
with
the
an
other.
electron,
Now, let's make that
you
pattern
know,
with
we're
a whole
talking
bunch of
about something
baseballs.
so
I'm gonna use
small,
the
and the
stitching
difference
machine.
in scale between the
Here's
two
the first
objects
one.
is
Let's see
huge.
what happens.
So, yeah, you would expect that, except for you're not taking into account any type of gravitational or
Now you see, the
magnetism,
balls landed
any
on the
type of
screen
force.
in two bunches,
The only thing you're taking into
pretty
account
much
is
along a direct
velocity of
line
this
from each of the
object
two holes.
flowing.
That's natural. That's what we expect.
Yada yada. This guy keeps
But when we
rambling
descend
on and
into the
about
microscopic universe and use
how this
electrons,
is
which
so
are 10 trillion
amazing.
times smaller than baseballs,
Now this
we get a
is where
very
he gets into
different,
the deep
odd
end.
result when we perform this experiment.
Now it's
a
not a
pattern
particle,
that
it's
you would
a
expect
wave.
if these were waves
And,
going through both
look at
holes at the
this.
same time and interfering
It
with
seems
themselves.
to follow this weird, strange
Well, we usually
pattern.
think of electrons as
it
being
couldn't
particles.
be the divergence
so how
of
can
paths
they
based
exhibit
on
wave-like
angular
properties?
math and
These test
exaggeration
results were
of
confounding.
curves. Nothing like
The
that.
electron
no,
was a particle
couldn't
before it
have
was
been.
fired
It's
at the
gotta
screen.
Be that
Yet it
particles
formed a
can now
pattern
be
on
in
the
two
screen,
places
as
at
if
once.
this single electron had
Make
gone
it
through
time
both
travel.
holes at the same
And they
time.
can do all these things because, you know, he's talking about
Does a
seeing this
microscopic particle
electron,
spontaneously
but you
clone
can't
itself
see
in
an
midair?
electron. We detect electrons.
After years of study,
And when we
scientists
detect
still don't know
electrons, we
exactly
use
what's happening.
various different pieces
Probably
of equipment to
the most
do that.
magical thing is
And
that in quantum
just like
physics,
anything
an
of that
object can be
size,
in
he
more
says
than
in
one
this movie
place at the
multiple
same
times,
time.
whenever you observe something, you affect
It actually
when it's that
can
small.
sense both slits and actually go through and quantum
See,
mechanically
these people have
feel
just
the
gone
structure of both
crazy.
slits in the experiment.
They would rather have these
Most physicists
magical
agree that
ideas,
the math is quite solid
and I think
and
it
leads
really
to
just bases,
solutions that
goes
are
back
undeniable
to, you know,
and
like
can be
searching for a
confirmed with
God,
experimental
and
measurements.
this gives them the set.
But exactly
that
what is happening and how
place
is a
where
matter
they
of
can,
debate.
you know, say, look at how magical this
To
is.
try to
and
grasp
it's
this
godlike.
amazing experimental
Blah,
result,
blah, blah,
scientists decided to
I'm
observe
pretty
how
sure if God
individual
wanted to,
electrons
you know,
behaved
state his
when they went
business
through the
or
double slit.
proclaim his existence, he would,
How exactly
you know, put
could a
his name
particle go through
underneath a
both
rock
holes at the
somewhere.
same time?
So here we go.
Scientists got a
Apparently,
front row seat
objects
to
are in two
observe the
places
strange
at once,
behavior of
and-
these electrons or
and they
other
split
subatomic particles
and,
or even photons
blah,
of light.
blah, blah.
Doesn't really matter as long as they're small. They didn't just look at where they landed on the screen back there. They also watched the behavior of the particles as they went through the holes. And then they saw something amazing. When scientists were watching the holes, the electrons behaved like particles, forming the baseball-like pattern on the screen back there. But when the scientists weren't watching, then the electrons behaved like waves. They formed a pattern that looked like the interference pattern produced by waves on
Okay,
a
so
screen.
I want you to see this pattern
That's really
here, this
strange.
divergence
What you see
pattern
depends on
with
whether you're
gaps.
watching or not.
And
if you're
I'm going to
watching, you see
recreate
the
this
particle-like
with
behavior,
some
like
simple,
baseballs. If you're not watching, you see a
simulation
wave-like
software.
behavior.
Here is our physics simulation. We have our particle, our wall, and our slits. And they are attracted. So you can see that arc curve. The particle came by. This object was attracted. And the path, the trajectory of the particle changed. Now, watch what happens when we try to pick like right in between two objects. So we try to cancel them out. Oh, it's kind of straight. What happens when we get closer to the wall? Oh, all of a sudden it bends. What happens when we get obscenely close to the wall? Oh, what happened there? Uh-oh, the particle's acting like a wave. Oh, we better decide that you know, small particles don't behave like objects, or it's magic. Look, it's got a wave pattern here, and it's no longer a particle, and it can be in multiple spots at once, and blah 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 blah. You know.